This is topic 37, related rates. So notice that I'm going to follow the steps here on this problem, so you can kind of look back up here in case you're wondering what the next thing I'm going to do. Okay, so on example 1, we have water that's being poured into an inverted conical tank, and the conical tank has a right circular cone with a height of 16 meters and a base radius of 4 meters. All right. Now the water is being poured at 2 cubic meters per minute. Now the question is asking, how fast is the water level rising when the water in the tank is 5 meters deep? Okay, so on problems that have to do with volume, I would probably draw a picture. Alright, so I have something that looks like this, and this is a right conical, right circular cone. This is 4 and this is 16. Notice those are the dimensions that they were giving to us. This is 4 meters, that's 16 meters. Alright, now the next thing I have to do is I have to write all the given information. Alright, notice that right here they're giving us the height and the base radius. And it's also giving us this number right here, 2 cubic meters per minute. Alright, water is being poured into a conical tank at 2 cubic meters per minute. Now this right here, if you look at just cubic meters, you'll be able to notice that's a volume. Now when you have a per minute, that's a rate. Alright, so this right here, I'm going to express that rate as a derivative, because the volume is changing over time. Alright, so I'm going to write this as 2 meters cubed per minute. Okay, now what I'm trying to find, alright, I'm trying to find how fast, and that's another rate. That should kind of give you a hint that the next thing you're going to write is going to be also a rate that you can express as a derivative, right? How fast is the water level rising? So as water is being poured into that cone, the water is rising, all right? So the water is rising. So I'm going to say that this is dH dt. So we're going to try to find the change in height over time, okay? When H is 5. Notice that the tank already has 5 meters of water, right? So the level right now is 5 meters, right? So the first thing you're going to do after this, after you have written all this, right? I would call this the first step after you figure this out. Sometimes this is the hard part, right? The next part should be relatively easy. Alright, the first thing you're going to do is you're going to try to find an equation or a formula that relates volume and height. Alright, now if you look in the back of this one, there's the formula for volume of a cone. Alright, so the volume of a cone is 1/3 pi r square h. So that's what I'm going to write here. And then now normally what would happen after that is that you can take the derivative of that. Notice that this is v and this is r and that's h. I'm trying to find dH dt, so that means I'm going to have to take the derivative of that. Now what makes this problem a little bit difficult is that I don't have anything that has to do with radius. If I take the derivative of this as it is, I'm going to have a dr dt, which I don't have any information on. Alright, so what I'm going to do, which is this is on this instructions here, we're going to use geometry of the situation to eliminate one of the variables by substitution. Alright, so I know that the radius, if I have a ratio of radius over height, that's 4/16. And notice that I do have h and I do have dH dt, so in that case I should probably solve for the radius. Let's see, I would have 16r is equal to 4h. And I would solve for r, and I would have h over 4. So I'm going to replace this r right here with h over 4, and then that way I have all the variables. I only have one variable here now. Alright, I have h and h here, so that's going to make my problem easier. So if you multiply all this stuff together, if you square this first and multiply times that, you get pi over 48 h cubed. Alright, so that's what you have. So once you figure out your formula and you have eliminated one of the variables, if you need to, you don't always need to do that. then you're going to take the derivative, all right? So I'm going to take the derivative with respect to time of both of these things. So this is going to be dv dt, okay? Now I'm going to take a derivative of this, and this is also going to be a type of chain rule, all right? So I would have pi over 48. The derivative of this is 3h squared times the derivative of h, which would be dh dt. Alright, so this is very similar to a chain rule, and if you don't understand why, you might want to go back and look at, I believe it was topic 36. Okay, so at that point right there, I'm going to try to simplify a little bit further. So notice that this right here would give me pi over 16 h squared dh dt. At that point, I'm going to plug, and I'm going to solve for this guy. That's what I'm looking for, right? And I have all this information, so I'm actually going to plug that stuff into this formula and solve for that. Right? Basically, there's a mistake that most people do when they're trying to do this. They try to plug in this h too soon. Don't plug anything until you have taken the derivative. All right, so now I can plug everything in. dv dt is 2. H is going to be 5. I'm going to square that. So it's going to be 25 pi over 16 dh dt. I'm going to solve for this. So my answer for that will be dh dt is equal to 32 over 25 pi, or 0.407. Now the units is important, right? So I don't care if you write the units when you plug it in, but you have to write the units for your final answer. Now because we're talking about a change in height over time, this is going to be meters per minute. And please, if you're going to use a calculator, round to 3 decimal places. All right, so we're going to round to 3 decimal places. Okay, so if that didn't make much sense, I feel like example 2 is much easier than that. So I would encourage you, if you're listening to this on video, to pause the video for a minute and read that problem and see if you can come up with this, write everything that you know about it, and then we'll go back to that. Now, assuming you have done that, all right, we have a spherical balloon. Okay, and we're going to say this is R, so we have a spherical balloon with a gas. A spherical balloon is inflated with a gas at a rate of 20 feet cubed per minute. So dv dt, notice that feet cubed per minute, that's a volume over time, all right? So this should be a little bit easier to understand if you just even look at the units, all right? So the volume is changing over time at a rate of 20 feet cubed per minute. How fast is the radius changing? So therefore, I want to find dr dt when the radius is 2 feet. When r is 2. Okay, so please be aware, right? The spherical balloon basically has a diameter of 4 or a radius of 2. So it's already at that point, and gas is being poured into the balloon basically. So you want to know how fast, how fast is the radius changing over time, okay? So if you did pause and did what I told you, you found that's pretty good, all right? Sometimes that's the hardest part. Now, like I said earlier, on step number 1, you're going to write the formula or equation that relates all of this together. So I know that the volume of a sphere is 4/3 pi r cubed. And now we're going to take the derivative, right? There's nothing for me, there's only one variable is r, and there's a v here. So there's nothing for me to substitute. So this one in a lot of ways is easier because there's not a substitution thing that I did on the last one. All right, so on number 2, step number 2, I should say, I'll take the derivative. dr dt. Okay, so make sure you understand how I got that derivative. That's going to cancel that. So I have dv dt is equal to 4 pi r squared dr dt. Okay, so now I'm going to plug everything in, alright? So now that I have taken the derivative, I'm going to plug in what I know. So I'm going to plug in that for dv dt, 4 pi, my radius is 2, and I am going to solve for dr dt. Okay, so I'm going to come over here now. So I have 20 is equal to 16 pi dr dt. Notice again this is 4. When I multiply it times 4 pi, I get that. Right, so at that point you divide both sides by 16 pi. So dr dt is equal to 20 over 16 pi, which is equal to 0.398 feet per minute. Again, I want to see those units. Okay, I want to see those units. Anyway, well, that's pretty much it. This can be difficult for some people, so if you got any questions, make sure and ask me when I see you again.